Welcome to the spoken tutorial on preparation of standard solutions. In this tutorial, we will learn to prepare standard solution of 1 molar sodium chloride. To follow this tutorial, you should be familiar with higher secondary school chemistry. Here I am using Mac OS version 10.10.5, ChemCollective vlabs version 2.1.0. Java version 8. To run this application smoothly, please install latest version of Java. Here I have opened Virtual Chemistry Labs application window. We will begin by preparing standard solutions from solids. Go to File menu and select Load Homework option. Default Lab Setup dialog box opens. The dialog box lists a number of local problems. From the list, double-click to select molarity and density. From the submenu, double-click on Making Solutions from Solids. On the left panel, Stockroom Explorer opens. It displays the required solutions and the problem description. Double-click on Problem Description icon. A problem description window opens next to the workbench. Window briefly describes list of problems you need to solve. Let us start with the first problem. We need to prepare 100 ml of 1 molar sodium chloride solution. Switch back to the workbench by clicking on Workbench tab. On the right side panel, Stockroom Explorer opens. It lists various chemicals to be used for this experiment. It has distilled water for making solutions, some solids such as sodium chloride, magnesium chloride and sodium sulfate. Let us place the required chemicals and apparatus on the workbench. Double-click on sodium chloride and distilled water icons. Sodium chloride bottle and distilled water are added to the workbench. Click to select Tools. From the drop-down menu, click on Scale. Scale appears on the workbench. Go to Click to select New Glassware from the drop-down menu icon. Select Erlenmeyer's. From the submenu, select 250 ml Erlenmeyer flask. Go to Select New Glassware icon. Select Volumetrics. From the submenu, select 100 ml volumetric flask. Again click on Select New Glassware icon. Select Pipettes. From the submenu, select 5 ml pipette. Molar mass of sodium chloride is 58.44 gram per mole. Use the given formula to calculate molarity. For 100 ml of 1 molar solution, we need 5.844 grams of sodium chloride. Back to the workbench. Drag the scale to a convenient position on the workbench. Click on Erlenmeyer flask and drag onto the scale. Release the mouse button after you see a green plus mark. Green plus mark indicates suitable position for placing the Erlenmeyer flask. Release the mouse button to place the Erlenmeyer flask on the scale. Scale shows mass of the Erlenmeyer flask. Click on Tare button on the scale. This step will reset the weight value to 0. Scale reads 0 grams. Click on Sodium chloride bottle and move it over to the Erlenmeyer flask. Place the bottle in the correct position after it shows green plus mark. Type 5.844 in the transfer amount text bar at the bottom of the workbench. Click on Pour button. You can see that the scale reads exactly 5.844 grams. Click and drag sodium chloride bottle to a different place on the workbench. Remove the Erlenmeyer flask and keep it aside. To remove the scale from the workbench, click on the scale and press Delete. Drag the distilled water onto the 250 ml Erlenmeyer flask. Type 90 in the transfer bar below. Click on Pour. This will transfer 90 ml of distilled water into the flask. Drag and place the distilled water to a corner of the workbench. Place the volumetric flask next to the Erlenmeyer flask. Click and drag the Erlenmeyer onto 100 ml volumetric flask. Make sure that green plus mark appears. To transfer the contents of the flask, use Realistic Transfer option. Click on Tools menu, scroll down and click on Transfer bar. From the submenu, click on Realistic Transfer Radio button. Realistic Transfer scale appears at the bottom of the workbench. Click on Pour button. Hold the left mouse button until entire amount has been transferred to the flask. To wash the Erlenmeyer flask with distilled water, place the water tank over the Erlenmeyer flask and transfer 5 ml distilled water. Change the transfer bar to Precise Transfer using Tools menu. Type 5 in the transfer bar below. Click on Pour button. Now pour the contents of the Erlenmeyer flask into the volumetric flask. To transfer the contents of the flask, use Realistic Transfer option. Click on Pour button. Hold the left mouse button until entire amount has been transferred to the flask. Change the transfer mode to Precise Transfer. Place the distilled water above the Erlenmeyer flask. Transfer 5 ml distilled water into the Erlenmeyer flask. Type 5 in the transfer amount text bar and click on Pour. Move the distilled water to a corner of the workbench. Move the 5 ml pipette onto Erlenmeyer flask. Type 5 in the transfer amount text bar and click on Withdraw. 5 ml of water is withdrawn into the pipette. Drag the pipette onto 100 ml volumetric flask. Change the transfer mode to Realistic Transfer using Tools menu. Click on Pour button gradually so as to make up to the mark. For colorless solutions, the lower meniscus must be on the 100 ml mark. Click on the standard flask. We now have 100 ml of sodium chloride solution as indicated in the Solution Info panel. Click on the standard flask. Solution Info panel on the right displays the species and the corresponding molarity. Observe that the concentration of sodium cation is approximately 1 molar. Go back to Problem Description window. Similarly, you can also try some of these problems. Let us summarize. In this tutorial, we have learned to prepare 100 ml of 1 molar sodium chloride solution. As an assignment, prepare the following standard solutions. 200 ml of 5 molar sodium chloride solution. 500 ml of 10 normal magnesium chloride solution. The video at the following link summarizes the spoken tutorial project. Please download and watch it. The Spoken Tutorial project team conducts workshops using spoken tutorials and gives certificates on passing online tests. For more details, please write to us. Do you have questions in this spoken tutorial? Please visit this site. Choose the minute and second where you have the question. Explain your question briefly. Someone from our team will answer them. The Spoken Tutorial forum is for specific questions on this tutorial. Please do not post unrelated and general questions on them. This will reduce the clutter. With less clutter, we can use these discussions as instructional material. Spoken Tutorial is funded by NMEICT MHRD Government of India. More information on this mission is available at this link. This tutorial is contributed by Snehalata Kaliappan and Madhuri Ganpati from IIT Bombay. Thank you for joining.